Hello everybody, today I'm going to show you hierarchical cluster analysis using R Studio. And in the coming cluster analysis tutorial, I provide a solid introduction to one of the most popular clustering methods. And today we will see hierarchical clustering in R Studio. And as all of you know, that hierarchical clustering is an alternative approach to k-means clustering for identifying groups in the data set. And it also doesn't require us to pre-specify the number of clusters to be generated as it's required by the previous approach or k-means approach. Moreover, hierarchical clustering take an advantage over k-means approach because it results in an attractive tree-based representation of the observation and what we may refer as a dendrogram. So today in this video we try to see the basic package requirements to run hierarchical clustering, and also we will see the detail about the hierarchical clustering algorithms. That means a description of different types of hierarchical cluster algorithm, and we will prepare our data for a cluster analysis, and also we analyze using hierarchical clustering with R Studio, and finally we will work with the dendrogram. That means understanding and managing dendrograms. So in order to analyze hierarchical clustering in your R Studio, the following package is required. The first one is the the package dend_extend, which is important for comparing two dendrograms. And the second one is the library factor extra, which is helping for clustering visualization. And the third one is the package tdiverse, which also used for the data manipulation. And lastly, the cluster. So coming to the hierarchical cluster algorithm, coming to the hierarchical cluster algorithms. And hierarchical cluster algorithms can be divided into two main types. The first one is the agglomerative, and the other one is the divisive method. And in the agglomerative or clustering methods, sometimes we may refer it as edgings or agglomerative nesting, and its work in a bottom-up manner that each object is initially considered as a single element cluster or a leaf. And at each step of our algorithm, the two clusters that are the most similar are combined into a new bigger cluster. What that means, that create a node, and this procedure is iterated until all points are a member of just one single big cluster. That means the root, that means the big one. So it will working from the bottom up manner. So it will start from the single element clusters that we may call it the leaf, then pass to the most similar are combined into a new bigger cluster, the nodes, and finally the procedure is iterated until all the members of just one single big cluster, the root. So it comes from the leaf, then the nodes, then the root. While the second algorithm is the divisive hierarchical clustering, it is the reverse of the agglomerative clustering, and sometimes it also known as the Diana or the divisive analysis, and it works with a top-down manner. It is the opposite of the agglomerative. The agglomerative working in what manner? It is the bottom to up, while he is the top to down. So the algorithm is an inverse order of edgings, and it begins with the root, and in which all objects are included in a single cluster. Then, so at each step of iteration, the most heterogeneous cluster is divided into two. So this process is iterated until all objects are in their own cluster. So the divisive method, or the Diana, it is the opposite of what? The agglomerative. So it will start to the root, then to the node, and the leaf. So these are the hierarchical clustering algorithms. And as we previously learned in the K-mean tutorial, we measure the similarity or the dissimilarity of observation using distance measures. That means we use the Euclidean distance method, Manhattan, and etc. So in R Studio, the Euclidean distance is used by default to measure the dissimilarity between each pair of observation. And as we already know, it is easy to compute the dissimilarity of measure between two pair of observation with the getDist function. And however, the bigger question is, how do we measure the dissimilarity between two clusters of observation? So this must be answered. So there are a number of different cluster agglomeration methods. That means the linkage methods. The linkage method, that means there are different linkage methods. One the complete, the other the single, the other is the word, the other is the centroid, and also the mean or the average linkage clustering. So to answer the dissimilarity, to answer that question means to measure the dissimilarity between two cluster observation, the agglomeration method or the linkage method have been developed to answer to this question. So the most common type methods are the maximum or the complete linkage clustering, the minimum or the single linkage clustering, and thirdly the mean or the average linkage clustering, for the centroid linkage clustering, and lastly the word is minimum variance method. Let's see them by detail. And the maximum or the complete linkage clustering is computes all pairwise dissimilarities between the elements in the cluster and the cluster 1 and also the elements in the cluster 2, and consider the highest value or the maximum value of this dissimilarity as the distance between the clusters, and it tends to produce more compact clusters. And secondly, it is a minimum or the single linkage cluster. It is opposite of the maximum. It computes all pairwise dissimilarities between the elements in the cluster 1 and 2 and consider the smallest. In the case of maximum, it's considered the maximum or the highest value, and while in the minimum or in the single linkage, it considers the smallest dissimilarity as a linkage criterion. So it tends to produce long, loose clusters, while in the case of maximum, it creates or tends to produce more compact cluster. And thirdly, the mean or the average linkage clustering. It computes all pairwise dissimilarities between the elements in the cluster 1 as well in the cluster 2, and consider the average of these dissimilarities as a distance between the two clusters. Yeah, it is what? It's an average, but that one is the maximum, the other one is the minimum. But here it considers the average of the dissimilarities as the distance between the two clusters. And the fourth one is the centroid linkage clustering. So this also computes the dissimilarity between the centroid for the cluster. That means the cluster 1, that means a mean vector of length of the p variables, and the centroid for the cluster 2. And lastly, the word minimum variance method. It minimizes total within cluster variance, and at each step the pair of clusters within minimum between cluster distance are coming together or merged. So to perform a cluster analysis in R Studio, generally your data should be prepared in the following manner. The first one, the rows are observation or individuals, and the columns are variables. The second one, if you have any missing data and if you have any missing value in your data, you must be removed or estimated. And thirdly, your data must be standardized in order to make variables comparable, as well as this may consist of transforming of the variables in such a way that to have a mean 0 and standard deviation 1. And for this tutorial, we will use United States of America R rests, or the data name is USA R rests, which contains statistics in arrest per 100,000 residents for assault, murder, and rape in each 50 states in 1973, and it also includes the percent of the population living in the urban area. But the first step is to, as mentioned before, you must be remove any missing value that may be present in your data. So in order to do that, you have to type this one. First, we have to assign USA restes, which is built in our studio, into df. So you have to type df and write this syntax or formulae. Then, in order to remove any missing value in your data, type this one. Then def is our data. Then na.omit means it's a removing of missing value in case if we may have. So run in this way. Then also the second one is if you must be scale or standardized to have a mean there in the standard deviation 1. Maybe it is consistent through different transforming techniques. So to do that, type this one is your data name is df, then scale, then write our data name df. So if you type this and run, your data must be standardized or scaled. And so the third one, let me check it, maybe whether it is standardized or not. So here is the Alabama, Alaska, Arizona, Colorado. So it is a good indication. And coming to the hierarchical clustering, to do hierarchical clustering in R Studio, there are different functions available for computing of hierarchical clustering. The most commonly used are the two. That means, as I mentioned before, there are two types of clustering. The first one is the agglomerative clustering, and the second one is the divisive hierarchical clustering. So in this case, the first one is using the function of hclust, which is found in stats package, and the second one is the agents, which is found in the cluster package. So here we forget to run this package, so they are available. We are calling. If you don't have, you have to install it or download it from the internet. So lastly, it's the library cluster. So to do the most common one, hierarchical clustering method, or the most common function are the two. That means the first one is hclust in the stat package, and agents in the cluster package that help us to analyze for agglomerative hierarchical clustering. And the second one is the Diana, which is found again in the cluster package for the divisive hierarchical clustering. Later, in the upcoming video, we will see the divisive hierarchical clustering, but for time of being, we will see only the agents method, or the agglomerative hierarchical clustering using hclust as well as agents function, which is found in both the stats as well as cluster package. So as I mentioned before, before running to the agglomerative hierarchical clustering, we must perform calculate or compute the dissimilarity values with the dist, and dist is the function, and then feed these values into hclust, and also this specify the agglomeration method to be used. That means the complete, the average, the single, and lastly it's what? The word. Then we can plot the dendrogram using one of these methods. So to find the dissimilarity matrix or distance, as I mentioned before, R by default will analyze using the Euclidean distance measuring methods. So to do that, write here D, then this is the function, as I mentioned before, to compute the dissimilarity values for performing the agglomerative hierarchical clustering with hclust. We must calculate or compute the dissimilarity value using what? The dist, and then feed this value to what? To the hclust, and finally specifying the agglomeration method. That means the word, the complete, the single, or the average, whatever you want. So you have to do that way. So type this one in order to calculate or compute the dissimilarity matrix. So the distance we are going to measure using the Euclidean. So run here, and then in order to you have to set, or you have to mention the agglomeration method that you are going to use. So for this method we have to use the complete. You can also use a single, you can also use you can also use the average. So it depends on your interest and objective. So HC1, let me give any one that you want, and I give HC1, that means hierarchical cluster 1. Then you have to fit this, the distance, the dist with what? H class. So then here is the name that's given here, D, and the method, that means the agglomeration method to be used for this tutorial is a complete. Then write in this way, then run. So if you want to observe the plots using the tree-based or the dendrogram, so right here to obtain the dendrogram plots, then HC1, the name that's given here, then CX. TX is the character expansion factor, that means it's relative to the current power. So CX is 0.6 and hang is -1. Then let's run this. So in the left corner, in the left corner there is the cluster dendrogram. It is clustering into different groups, So by this way we can obtain the cluster dendrogram using the agglomeration method, the complete. But alternatively, we can use the agents function, and these functions behave very similarly. However, with the agents function, you can also get the agglomerative coefficient. Yes, it's coefficient. So, which measures the amount of clustering structure found. That means the more you get, or the more closer to one, it suggests a strong clustering structure. Let's see it. So to do that, we have alternatively we can use using the agents. So in order to get that particular coefficient, that means if you get 0.9 comparing to 0.7, 0.9 is close to 1, so this is very strong. That's suggesting to have good cluster structure. So to do that, HTC2, then write this the function agents, and df is our data name that we give here is USERSTS, and the method is a complete. Then run here. And also, in order to see the agglomerative coefficient, it indicates in terms of number. So write already this HC2 or hierarchical clustering 2 already given here. Then attach the AC or agglomerative coefficient. AC stands for the agglomerative coefficient. Then type this. Then run. So it gives around 0.85. But if you have, for example, if you use the word method and around 0.9 or 0.99, it is very close to 1, so it suggests you have what strong cluster structure. So let's check it if you want to do more, or if you want to assess within the given ranges. For example, here is the average, here is the single, here is the complete, here is the word. So by assessing the different agglomerative methods, which one is close to what? Assess different agglomeration methods. Here is the average, the single, the complete, and the word are there. So to do that, because assessing different methods allows us to find certain hierarchical clustering methods that can identify stronger clustering structure. So, for example, we have to run. Let's compare using the average, single, the complete, and the word. To do that, write this syntax or formulae, then run together in order to get the coefficient. Yeah, the coefficient. So over here, the average is gives 0.73, the single one is 0.62, the complete 0.85. And the word is around 0.93. So here we see that the words methods identify the strongest clustering structure of the 4 methods that we are assessed. So let me see the dendrogram that looks like before we see that the complete. So the best one is according to the coefficient that we've seen here, the word is the best. So write whatever you want here and write the function agents, then the data name is our df, the method is word, because word is close to 1. So the values closer to 1 suggests a strong clustering structure. So for this reason we have to use word, then run here, and let's see the plots or the dendrogram graph. So to do that, pl3, then this is the function, then h3, then the cx 0.6, the hang is -1, and the main title, that means if you want here, for example, if you say Wagjira here, it will be up Wagjira here over the main title. So dendrograms of agents, so run here. Yeah, let's zoom in. Yeah, so by this way, using the agglomerative method word, so we cluster our data sets in the following way. So this is all about the agglomerative method. So in coming video, I will come up with hierarchical clustering using the divisive method. And if you are not my follower, please subscribe to my channel. Those already subscribed to my channel, please provide your valuable comments. And if you have any question regarding to my tutorial, you can address me through my email wabjiratasfaun@gmail.com or through YouTube comment box. Thank you for watching. Have a nice time.